Chapter 8 is called Polynomials, and 8.1 is called Multiplying Monomials. So those words, poly and mono, in math, poly means many, and mono means one. So we're going to start out with a definition of what a monomial is. So monomials can be several different things. A monomial can be a number. It could be a variable. Or it could be the product, so multiplying the product of one or more numbers and variables. One or more numbers and variables. So if it could be a number like the number 3, it could be a variable like x, or it could be 3x, 3 times x, or it could be 3x squared, or 57ab, or 83a squared b to the third. So in this last one, it's just all things being multiplied. So when there's more than one thing to be a monomial, they just have to be being multiplied to each other. So when it's just a number, we call it a constant. Oops. A constant. And that's if the monomial is just one number. So we're going to look at some things and decide, is it a monomial or is it not a monomial? So -5. Yes, that would be a monomial. P plus Q. No, not a monomial, because they're not the product of two things, they're the addition of two things. Likewise, P minus Q would be no, not a monomial. Just plain X, yes, that's a monomial. C over D, no. So a monomial cannot have a variable in the denominator. No variable in denominator. But a monomial can have a number in the denominator. So yes, a, b, c to the 8th over 5, yes, that is a monomial. Now the next thing we're going to talk about is powers. So when you have a number to a little number, we call this, the little number, of course, is the exponent. And the big number is called the base number. The whole thing is called a power. So anytime you have a number to an exponent, it's called a power. And of course, what does it mean? 2 to the 5th means 2 being multiplied to itself 5 times. So if you do have to multiply these numbers out, it's best to do something like this. 2 times 2 is 4. 2 times 2 is 4. This 2 times 2 is also 4. And then I've got one more to multiply. So that would be 16 times 2, or 32. 2 to the 5th power is 32. So when I see 2 to the 2nd power times 2 to the 4th power, I'm going to write this out, what this actually means. 2 to the 2nd power means 2 times 2. And 2 to the 4th power, 2 times 2 times 2 times 2, 4 of them. Altogether, if you're going to add up all these 2's, I have 2 to the 6th power. So 2 squared times 2 to the 4th equals 2 to the 6th power. And what happens is, when the bases are the same, and you're multiplying, then you can always just add the exponents. So any number, a to the 3rd power, times a to the 4th power, is going to equal a to the 3 plus 4, or a to the 7th power. So the bases have to be the same, and when they are, you can always, and you're multiplying, you can always add the exponents. And that's the rule to remember. I'll be saying over and over, bases are the same, add them high. So when the bases are the same, means you just can add the exponents. In this problem, 5x to the 7th times 2x to the 6th. There's two things we're going to do here. The 5 and the 2 are not exponents, they're just normal numbers. So we can multiply them and get 10. The x to the 7th times x to the 6th means the bases are the same, so we're going to add them high and get x to the 13th. And that would be our answer. Let's do another one. 4ab to the 6th times negative 7a squared b to the 3rd. Okay, once again, the 4 times the negative 7 are regular numbers. Gives me negative 28. A times a squared. Well, when it's just an a and there's no exponent there, it has an exponent of 1, even though it's not written in. So a times a squared equals a to the 3rd. And now I'm going to multiply b to the 6th times b to the 3rd and add those exponents, and that would be b to the 9th. And that would be that problem. Let's do just a couple more. Negative 4mn squared, this is squared, times 12m squared n. Go ahead and try this problem on your own and see if you're getting it. So I'm going to multiply the negative 4 times the 12 and get negative 48. And then m times m squared, well, I have to add the 1 plus 2 and get m to the 3rd. And then n squared times n is also n to the 3rd. So negative 48, m to the 3rd, n to the 3rd. How about 3x to the 4th y squared z times x to the 3rd y? Okay, I'm multiplying 3, and there's no number here, but it's like 3 times 1, which is going to be 3. And then I'm multiplying x to the 4th times x to the 3rd, that's x to the 7th. Then y squared times y is y to the 3rd. And z times nothing over there, it'd be like z, it would be just z. So 3x to the 7th, y to the 3rd, z. Okay, now we're going to learn the next rule about multiplying with powers, and it's called power to a power. So this time, say I had 4 squared, and that whole thing is going to the 3rd power. Well, what does that mean? It means I have 4 squared times 4 squared times 4 squared, And now when the bases are the same, I can add those exponents. That would be 4 to the 1, 2, 3, 4, 5, 6. Well, if you go back and think about what you did, the shortcut is that when you have power to a power, you can multiply the exponents. So no matter what the number is, if you have x to the fourth, all of that to the third power, that's going to be x to the 12th. So we no longer have the base written out twice. The base is just written once, and we've got a power to a power. So that separates the two rules. The first rule, which was bases are the same, add them high. And the second rule, a power to a power, multiply. So it's kind of a rhyme. When you see the base twice, bases are the same, add them high. But if it's just power to a power, multiply. So bases are the same, add them high, power to a power, multiply. So let's try one of these. So if I have 3 squared to the third power, then that's going to be 3 to the 6th power. So sometimes I might tell you to actually work that out, and sometimes I won't. Usually when the exponents get this high, I don't say to write it all out. You can leave it as 3 to the 6th. Likewise, if I had 2 to the third power to the 4th power, and the whole thing squared. In this problem, there's a hard way to do it and an easy way. The easy way is that you're just going to multiply all those exponents. This equals 2 to the 3 times 4 times 2, which is 2 to the 12 times 2, 2 to the 24. And that's how you're going to leave your answer, 2 to the 24. Now, when there is more than one thing in parentheses, like say xy to the 4th power, this means that everything in the parentheses is going up to the 4th power. So that's going to equal x to the 4th, y to the 4th. Likewise, 6, a, b, all of that is in parentheses to the 3rd power. So it means 6 to the 3rd times a to the 3rd times b to the 3rd. 6 to the 3rd is 6 times 6 times 6, which is 36 times 6, which you would carry out to 216, a to the 3rd, b to the 3rd. Let's try negative 2xy to the 3rd. Now I'm going negative 2 to the 3rd power times x to the 3rd times y to the 3rd. Negative 2 to the 3rd means negative 2 times negative 2 times negative 2. This would be negative 8, x to the 3rd, y to the 3rd. Okay, let's try a couple more. Let's see. 3, y to the 5th, z, all of that in parentheses to the 2nd power. So everything in here has got to go to the 2nd. 3 to the 2nd power is 9. Y to the 5th to the 2nd is a power to a power, so I multiply y to the 10th. And z is going to be z to the 2nd. And that one's done. Let's make it a little more difficult now. If I have negative 2 x to the 3rd y to the fourth, all of that to the third power, times negative 3 x y to the third, all of that to the second power. So first I'm putting everything in the first parentheses to the third power. Negative 2 to the third power is negative 8. X to the third power, power to a power I multiply, is x to the ninth. Y to the fourth, then x squared, y to the third squared is y to the sixth. Now I've got to multiply these two things together. Negative 8 times 9 is negative 72. Now this is multiplying x to the ninth times x squared. This is bases written out twice. Bases are the same, so we add them high. X to the 11th. And then y to the 12th times y to the 6th. Bases are the same. I'm going to add those high. Y to the 8th. And then that's your final answer. Did I leave something out? Oh, I'm sorry, I did. This was a 12. It was y to the 12th times y to the 6th. That's y to the 18th. I missed that one right there. So that's the right answer. Okay, we're going to do a couple more like this. Let's try 5x squared y, all of that to the second power, times negative 2 x to the third y squared to the third power. So you can go ahead and try this one and then see if you've done it right. In the first parentheses, I'm doing 5 squared, which is 25. X to the fourth, y squared. In the second parentheses, negative 2 to the third is negative 8. X to the ninth, y to the sixth. Now I've got to multiply 25 times 8, 25 times negative 8, which is negative 200. Now I'm adding exponents because I have x to the fourth times x to the ninth. That's x to the 13th. Y to the 8th. Okay, I've got one more kind of tough problem. So you're going to see about the hardest ones in this section. 1/3 x, y to the fourth, all of that squared. Then braces, and inside the braces are parentheses, negative 6 y, that's going to go to the second power, and then all of that in the braces will go to the third. So I'm going to start by squaring. 1/3 times 1/3 is 1/9. X squared, y, I'm multiplying to the 8th. That's my first parentheses. In the braces, I've got negative 6 to the second power, which is negative 6 times negative 6, which is 36. Y squared. And then I've got to put those to the third power. Okay, now I have to put what is in this parentheses to the third power, which means I have to put 36 to the third power, which means I have to multiply 36 times 36 times 36, which isn't something I would ask you to do without a calculator. So normally the numbers would be smaller. But 36 times 36 times 36 is 46656. and that would be y to the 6th. And now you have to multiply that times 1/9 x squared y to the 8th. So when you're multiplying 1 over 9 times 46656 over 1, you're just dividing that. So that divided by 9 is 5184. Now I'm doing x to the 6th, x squared, sorry, and then y to the 14th power. And that would be the final answer of that one.